Hello and welcome. This is going to be our lecture video for April 13th. For this lecture, I'm just going to go over this worksheet linked on my calendar where I'm going to go over a few special sequences, just sort of unique sequences that I thought would be fun to add into our unit on sequences. The two that this worksheet goes over are the triangle numbers and the Fibonacci sequence. Print this down or just take notes. Even though these are just kind of unique fun sequences, I still like to write test questions about triangle numbers and the Fibonacci sequence very frequently, so be ready for that. The triangle numbers starts 1, 3, 6, 10. Draw the corresponding picture to carry this pattern on to 8 terms. So why they're called the triangle numbers is it's the number of blocks you would need to make a triangle as tall as the number's position in the sequence. So for the first number in the sequence, how many blocks do we need to make a pyramid 1 block tall? Well, it's just 1 block. But for the second position, we're trying to make a pyramid 2 blocks tall, so we got to put 2 across the bottom, and then we can balance 1 on top. So it's a triangle, it's like a pyramid. So that's where we get the 1 and then the 3. And then to make a pyramid 3 blocks tall, you got to put 3 across the bottom, 2 on top of that, 1 on top of that, that's 6. All right, we're going to carry this on to 8 terms. Pause the video here and draw out the rest of these. You can try it on your own, see if we get the same numbers. All right, so here I have all my triangles written out to a triangle that'll get you 8 blocks high, and that took 36 blocks because you had to do 8 across the bottom and then 7 across those and then 6 across those. So you can see these numbers, they start to grow pretty quick because you need a bigger and bigger base each time to make your pyramid. But can we come up with a formula for finding this triangle number? So here, let me take you to a blank page and we'll see if we can come up with this formula. So for the first one, it was just 1. The next one was 1 plus 2. The next one was 1 plus 2 plus 3. The next one was 1 plus 2 plus 3 plus 4. Well, you might notice these are arithmetic sequences. So we can use our formula for finding the sum of an arithmetic sequence to figure out what the sum of these is going to be without having to write out all of that addition. So, let's say we want to go all the way to the 10th. That's going to be 1 plus 2 plus ... plus 10. Well, the trick for figuring this out was you took the biggest number and the smallest number and you averaged them. So we did 10 plus 1 divided by 2, and that gets us 5.5. Then we multiplied it by the number of numbers. Well, here there's 10 numbers. Okay, so now replace 10 with x, and you've got your formula. So for the xth row of this pyramid, or for the xth triangle number, you can just do x plus 1 divided by 2 times x. So there's your formula. X plus 1 divided by 2 times x. And then this can be simplified if you really want to. It could be x squared plus x all over 2. Either way, those are both good formulas for your triangle numbers. So can we find the next 4 triangle numbers? So for the 9th, that's going to be 9 plus 1 over 2. So that becomes a 5 times 9 equals 45. All right, so for the 10th, well, we just did that one as a practice one. Did we finish solving it? No, we did not. 5.5 times 10 equals 55. So the 10th was 55. For the 11th, that's going to be 11 plus 1 over 2 times 11. So that becomes a 12 divided by 2, 6. So that's a 66. See if you can get the 12th. And the shortcut would be to just do 66 plus 12. You get 78. All right, can we get the 20th triangle number? Let's try that. Divided by 2 times 20, 210. So what this is saying is that to build a triangle 200 blocks tall, you're going to need 210 blocks. All right. So there's enough ground for you to lay 22 logs side by side. If you stack the logs up so that you make a triangle, how many logs can you fit in the stack? So this is what we're dealing with. We've got our logs lying on their side, and the face of those logs is going to make a pyramid. Well, the stack 22 logs wide would also be 22 logs tall. So we can just find our 22nd triangle number to answer this. So just do 22 plus 1 divided by 2 times 22. Try that in my calculator. We get 253. We can stack 253 logs here. And that would be the same. That's exactly what we would get if we did 22 plus 21 plus 20 ... all the way to the last one. And that would mimic how many logs are in each row. All right, question 6. Jade has crash landed in the desert. There's a village somewhere nearby, but the direction is unknown. So Jade comes up with the following plan. He's going to walk 1 kilometer north, change direction, walk 2 east, then 3 south, 4 west. And so he's going to make a spiral by doing this. So, 1 north, 2 east, 3 south, 4 west, 5 north. All right. How far will he have walked when he reaches the end of his 10-kilometer stretch? So he just keeps doing this until at one point he turns the corner and walks 12 kilometers straight in one direction. How far total has he walked? Well, to figure that out, we would do the 1 plus the 2 plus the 3 all the way up to the 12. Well, that's just the same formula again. All right, so we just want our 12th triangle number. So we do 12 plus 1 divided by 2 times 12. 13 over 2 times 12. We get 78. He'll have walked 78 kilometers. So we should give this the unit up here of logs. Okay, on to our next sequence. It's the Fibonacci sequence. So the Fibonacci sequence starts out 1, 1, 2, 3, 5, 8. Where are these numbers coming from? Well, to figure out the next number in the Fibonacci sequence, you just add the previous two. So we start 1, 1, 2, 3, 5, 8. Well, I add the 5 and the 8 and I get 13. I add the 8 and the 13 and I get 21. Here I'll pause again and I'll write it all the way out to the 20th. We'll see. You try it on your own. We'll see if they match. All right, you'll know you have done it right if your 20th Fibonacci number is 6,765. All right. Question 8 says write out the first 16 terms again and circle each number that's divisible by 3. How often do they occur? So we got to talk about a trick for divisibility here. If the sum of the digits is divisible by 3, then the whole number is divisible by 3. So let's check with a couple numbers. 13. 1 plus 3 is 4. That's not divisible by 3. 21 is 2 plus 1. That's 3. 3 is divisible by 3. Let's see. No, no. No, nope. Yes. This one is divisible by 3. No. Nope. No. 6 plus 7 plus 6 plus 5. That's 24. This one is divisible by 3. So it's every 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. But this one wasn't. So it's every 4, but it skips. Oh wait, no. 1 plus 4 plus 4 is 9. Okay, it is every 4. Yep, so every 4. Every number divisible by 5. Let's see. So the trick with divisible by 5 is just if it ends with a 0 or a 5. And let's see how often that happens. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Looks like it's every 5. All right, what numbers would you get if you continued the pattern backwards? So we know the two previous numbers have to add up to the next number, so what would happen if we went backwards? So I'll write my 1 and 1 over here. So what number plus this 1 would get this 1? Well, it's 0. Now what number plus this 0 equals a 1? Well, you'd have to do a negative 1. No, wait, we'd want a 1 there. We're not negative yet. Here's where it gets negative. We need a negative 1 here. And now what number plus negative 1 gets a positive 1? It's a positive 2. What number plus 2? This is a negative 3. And I'll let you keep going with that. It's kind of an interesting exercise to just challenge your brain, see how far backwards you can go with the Fibonacci. And you get all these negative numbers. And I think it always alternates positive, negative going backwards. But it doesn't exactly mirror the Fibonacci sequence. So you can see you don't have 1, 1, 2, 3. Well, let's see, what number? 5, so it is kind of mirroring it. Negative 8. Okay, so it does mirror Fibonacci sequence, but it does alternate positive and negative. Okay, that's that for this video. Have a good rest of your day.